Hi guys, in today's video we're talking about complex numbers and we are going to prove the de Moivre's formula. So it says that cosine of theta plus I sine of theta all to the power of n, this is equal to the cosine of n theta plus I sine of n theta. So we are going to prove this by induction. Our p of n is basically this, we can copy it down. So this is our proposition. So first we're gonna check whether this proposition holds for the base case. So let's see if p of 0 is true, right? So p of 0 is gonna be cosine of theta plus I sine of theta to the power of 0, because basically we're gonna substitute 0 every time that we have n. So this is equal to cosine of 0 times theta plus I sine of 0 times theta. Now this implies anything raised to the power of 0, we know that is equal to 1, so the left hand side is equal to 1, and here cosine of 0 is equal to 1, right? And sine of 0 is equal to 0, so this is gonna disappear. So this is 1 plus 0, so this implies that 1 is equal to 1, and this is true, right? So p of 0 is true. Now we're gonna check whether p of n true implies that p of n plus 1 is true. So we're gonna assume p of n to be true, and our goal is to prove that p of n plus 1 is true, right? So our p of n plus 1, let's write it down here, is basically substituting n plus 1 every time that we have n here, right? So our p of n plus 1 would be cosine of theta plus I sine of theta all raised to the power n plus 1 is equal to the cosine of n plus 1 theta plus I sine of n plus 1 theta. So basically we need to prove that this is true, right? Assuming that our p of n is true. So this is our left hand side, this is our right hand side. So our goal is, starting from the left hand side, our goal is to get the right hand side, right? So this is our goal. Now we're gonna start with the left hand side, so let's copy it down here. So we're gonna start with this. So the left hand side is equal to this. Now our goal is to get the right hand side. So this is equal to cosine of theta plus I sine of theta to the power of n times cosine of theta plus I sine of theta. Now since we assumed that p of n was true, so basically as you can see, this is equal to this, so we can copy this right hand side substituting it here, right? So if we copy this, this is gonna be equal to, we paste it here, this times this one here, right? So times cosine of theta plus I sine of theta. Now we can multiply and remove the brackets, so this is equal to the cosine of n theta. So we multiply this by this and then this by this, right? So we're gonna get cosine of n theta cosine of theta, then we have plus I sine of theta cosine of n theta, then we have plus I cosine of theta sine of n theta. So lastly we have I here, I here, so we have I times I, which is basically I squared, and I squared we know that it's equal to -1, so the sign is going to be minus here, and we have sine of n theta and sine of theta, right? So sine of n theta times sine of theta. Now we can factorize here because we have I and I, so we can factorize, and basically this we're gonna write it down as it is. So this is equal to cosine of n theta cosine of theta. Then we have this, so we can copy and paste, minus this, and here we're gonna factorize, so plus I times we have sine of theta cosine of n theta plus cos of theta sine of n theta, right? So we have sine of theta cosine of n theta plus cosine of theta sine of n theta. Right, now if we remember properties of sine of and cosine, if we have, for example, sine of alpha beta, this is equal to sine of alpha cosine of beta plus sine of beta cosine of alpha, right? And if we have cosine of alpha beta, this is equal to cosine of alpha cosine of beta minus sine of alpha sine of beta. These are properties of sine and cosine, right? Now as you can see here we have cosine of alpha cosine of beta, which is basically cosine of n theta cosine of theta. Then we have minus sine of alpha sine of beta, so minus sine of n theta sine of theta. So this basically can be reduced to just cosine, and then we're gonna add up the terms, right? So this is basically the cosine of n theta plus theta. Similarly here, as you can see, we have sine of alpha cosine of beta, so here sine of alpha cosine of beta, and then we have plus sine of beta cosine of alpha, so we have sine of beta cosine of alpha. So this can be reduced basically in the sign, and we just add up the terms, right? So this is basically sine of alpha plus n theta. Now so we can write it down properly. So we have cosine of n theta plus theta plus I sine of theta plus n theta. That's what we have here. Now here we have a factor theta and a factor theta similarly here. So this is equal to, if we factorize theta, this is equal to the cosine of theta times n plus 1 plus I sine of theta times n plus 1. Now as you can see, if we go back to our goal, so p of n plus 1, we said before to prove it we need to get our goal, and as you can see we have it here. So basically this is equal to the right hand side, so we have left hand side here equal to the right hand side, so this implies that our p of n plus 1 is true, right? So this implies p of n plus 1 is true. So we can conclude that our p of n is true. So basically we have proven our de Moivre formula. So this is proven.